All right, next we're going to cover inequalities. So an inequality looks just like an equation, except that in place of the equal sign, we use one of the symbols, less than, greater than, less than or equal to, or greater than or equal to. Linear inequalities is what we will be solving. And just remember one thing, that the same rules are going to apply pretty much for equations as far as solving. You're going to try to get your x on one side, everything else on the other. Manipulating the equations, very similar to inequalities, unless for one, I guess with one exception, when multiplying or dividing by a negative number, you must reverse the inequality symbol. Okay, so before we solve, we're going to look at 3 ways that you're going to be asked to identify a solution to an inequality. One is what we call set builder notation. The second would be on a number line, and the third would be interval notation. Now, the first 2 don't seem to cause students a lot of problems. Sometimes interval notation does. Interval notation is a way to give answers that lie between 2 values. Okay, and most of our, equations do. Even though we can have greater than or less than, it can still say from 3 to infinity, or negative infinity to 3, and so on. Or it can be between 5 and 20. So that's what interval notation gives to us. The confusing thing about interval notation is it can look like a point on a graph. So we use parentheses and or brackets to identify solutions. Sometimes we use a combinations. We use parentheses if it's just less than or greater than, and we use brackets for less than, greater than, equal to, and less than equal to. So remember, your symbol for infinity is that sideways looking 8, and negative infinity is a negative in front of the infinity symbol. Okay, so let's look at set builder notation. So set builder notation is a lot like just inequality notation. The only difference is the way they organize it. Okay, so move here and not mess nothing up. So if I have between 2 numbers, that's a compound inequality. And the way we list that between 2 numbers is we say our x is in the middle, and since the bracket is here, that's less than or equal to, and then it's bigger than 2. So this is our solution for x be greater than 2 but less than or equal to 10. Now what set builder notation does, it takes that, and I believe most of the time you're going to be started off with this part of set builder notation if you do it on MyLabs Plus. And this is just kind of like these funny looking brackets, and they mean the set whose members are x such that x is between 2 and 10. That's kind of how you write it. So you're really just using the inequality notation and transferring it to this set builder notation, so it almost speaks a complete sentence in a way. Okay, part B is -5 to infinity. Well, what that really translates to is x is less than 5. Okay, so to write that in set builder notation, I have the set whose members are x, and this long line here means such that x is less than 5. Okay. And then the third one, we're going to come out here, is -3 to infinity, which means x is greater than or equal to -3. And then to put that in set builder notation, the set whose members are x such that x is greater than or equal to -3. So really what you're doing is you're taking these answers that are in interval notation and putting them back to inequalities. So this is your interval notation that I was talking about earlier. Okay, so if I want to work the other direction and now take answers in inequalities and put them into interval notation, this is x greater than or equal to 3. So I go from smaller number to larger number. So that would be 3 to infinity. I use the bracket because the 3 is included, and infinity always has parentheses because there's no end, so you don't have an ending point. On a number line, I can draw my number, identify my 3, put my bracket here, and then point my arrow in that direction. The other way you can identify your solution on a number line is you can do a shaded dot if it's equal to. So it'd either be this, or you can shade your dot with 3. For x less than -2, I always put the smaller number first. So I'm going to do negative infinity to -2. So that's my interval notation. On a number line, I can do identify -2. I can use my parentheses, make sure your arrow's going in the proper direction, or the other way to identify it is with a hollow circle, which does not include -2, because less than -2 does not include -2. The third way is, this is the compound inequality, where x lies between two values. So since this is -1 to 5, that's greater than -1, so we use the parentheses, and less than or equal to 5. And then on the number line, you can reproduce -1 to 5, and you can do the bracket and the parentheses, or you can do -1 to 5 with shaded and then hollow. So either one of these is acceptable for me. Sorry about that. Okay, so that's kind of how to show our solutions. Now we want to look at, well, solving. So, same rules apply. Don't forget that. I'm going to get my x's on one side, everything else on the other. So if I'm solving this inequality here, I'm going to subtract 9x from both sides. And that leaves me -6x less than 4. Now, I divide by -6, and when I multiply or divide by a negative number, I must reverse the inequality symbol and then reduce my fraction. So I flip the symbol when I divide by -6. Now, the compound inequality, I want to isolate x from the center. So when I want to isolate x from the center, that means I want to get everything away from the x, and whatever I do to the center, I must do to the right side and to the left side. So in order to get x by itself, the first thing I'm going to do is I'm going to add 2 to all 3 locations. Next, divide everything by 3. And there's my solution. So I do see oftentimes students have a lot of trouble with these compound inequalities, but just try to remember you're working from the center. Whatever you do to the center, you've got to do to the extreme outside. Okay, so just try to remember that and try not to overcomplicate it too much. Okay, so that's linear inequalities. The other type of inequality we're going to be looking at are the absolute value inequalities. So we had rules for absolute value equations. So if we had the absolute value of x equals some number, it equals the positive or the negative. Well, with absolute value inequalities, it depends upon what symbol you're given to how to create your two inequalities. So for example, if I have the absolute value of some expression is bigger than or equal to, then I apply this rule. I say what's inside the absolute value symbols is bigger than this number, or it's smaller than the negative. So think about bigger than 3 is 4, 5, 6, and then we also would want smaller than -3, which would be -4, -5, -6. It's just because we're dealing with absolute value. Now, if the absolute value equation is smaller than or equal to some value, then we create our compound inequality. So we put x in the middle, or whatever's inside the absolute value symbols in the middle, and then the positive and negative value on the outside. So let's see how it works. So if I have the absolute value of x minus 4 is less than 3, I apply this rule here. And so what I have is x minus 4 is less than 3, but bigger than negative 3. So it's got to be, you're thinking every time you make absolute value, it's going to be positive. So, less than 3 is whole numbers, 0, 1, 2. So therefore, it's got to be bigger than negative 3, which would be negative 2, negative 1, and 0. Okay, then I solve. Add 4 everywhere. So that gives me my x is between 7 and 1. Don't forget, it's whatever's inside here has to be smaller than 3, less than 3, okay? So my x values must be less than 7 but bigger than 1. To put that on a number line, I can do the 2 hollowed circles or the 2 parentheses. So that's illustrating, the one rule where it's less than or equal to. Let's look at one that is dealing with greater than or equal to. So in this case, when I have it set up where it's bigger than 7, I'm just going to create 2 separate inequalities. And I'm just straight up following this rule right here. Bigger than or equal to the number, less than or equal to the opposite of the number. And then I solve. So I subtract 5. So negative 2x greater than negative 2. And when I divide by negative 2, I must still reverse the inequality rule. Same rules still apply. So x, how about that, is less than 1. On the other side, subtract my 5. Watch your signs here. Remember, when the signs are the same, just add and keep the sign. Oh, and I forgot to graph this on a number line. Sorry about that. I'll graph them both when we're done. Divide by negative 2. Reverse the inequality symbol, so x is bigger than 6. So to graph the x less than 1 on a number line, I go to 1, do my parentheses, arrow left, x bigger than 6, do my parentheses, arrow to the right. Okay, so that's, solving your inequalities and your absolute value inequalities. We will do more in class, but that's pretty much the gist of it. What you have to try to avoid doing, and it's easy to do in math, is to confuse yourself. It's very easy with all these different types of equations, inequalities, terminology, to get confused and mix up procedures. But with practice, I think you'll be fine. Just make sure you do the practice.